Hello, my name is John Day and I'm here with Connor Stockton, and today we are here to talk you through the determination of a chemical formula lab.
The purpose of Part A is to determine the empirical formula of the product of zinc and iodide, and the purpose of Part B is to determine the formula for the unknown hydrate.
Some of the materials that we needed to do this experiment was a 50 and 100 milliliter beaker, hot plate, zinc metal and iodine, 0.2 molar acetic acid, crucible and a cover, and then Bunsen burner, iron ring and an iron ring stand, and wire gauze.
The procedure for this was to weigh out approximately 0.6 grams of zinc, and then you would weigh out approximately 0.6 grams of solid iodine. Then you would add the zinc to a beaker, approximately 5 milliliters of 0.2 molar acetic acid.
When we mixed these two substances together, we had to record the observations of that. Then we had to decant the solution into a separate beaker while making sure that the metals stay in the original beaker. We then had to do this 3 separate times to make sure everything was washed out of each other.
And then we added approximately 3 milliliters of 0.2 molar acetic acid to the solid zinc. We swirled it a couple of times and decanted it. We washed the zinc with DI water 3 times, and we dried the zinc on a hot plate. Then we removed it, and once it was cool, we weighed it and got the mass of zinc.
That's the end of Part A. To start Part B, we had to find the mass of an unknown hydrate that we were given to at the beginning of the lab period. We then had to heat gently for 5 minutes. If we heard any crackling or popping, then we had to take it off and wait till that sound was stopped, then put it back on. After 5 minutes, then we had to turn the heat up and wait another 20 minutes to heat it all up.
Once after the 20 minutes was over, we let it cool and then we recorded its mass. Then we turned the heat up for 5 more minutes. Then we let it cool down and waited again and recorded its mass then.
After we heated it up the second time, if the mass was closer to 0.1 gram away from the first mass that we took, then we are done with that substance. If it is not closer than 0.1 gram away from the first mass, we had to heat it again until it was closer to 0.1. So it could have been another 1 time of heating, another 2 times, it just depends. After that, we had to pour 6 molars of hydrochloric acid into a beaker.
We dipped a spatula into the hydrochloric acid, and then we lit a Bunsen burner and put the spatula underneath the Bunsen burner to make sure that the spatula was clean. Then we took a small amount of the unknown and put it on the end of the spatula, and then we put it up to the Bunsen burner, and if it turned bright red, we had a strontium chloride as our unknown, but that wasn't the case.
Alright, so at the beginning of Part A, we had to find the mass of the zinc, so we had to get the mass of the 50 milliliter beaker, so that would be we ended up with 30.13 grams. So then we had to get the mass with the zinc and the beaker, so that was 30.83 grams. So to find the mass of the zinc, we have to take the mass with the zinc and the beaker and subtract the mass of the beaker to find the actual zinc. So we can take 30.83 grams minus 30.13 grams, and that all equals up to 0.7 grams of zinc. So that's how we got the mass of the zinc. Then we had to do the same thing, but we had to find the mass of the iodine. So we had to take a mass of the weighing paper. So the paper is 0.35 grams. Mass of the iodine and the paper was 0.96 grams. So we had to take the iodine and subtract the paper. So that's 0.96 grams minus 0.35 grams. And that gave us 0.61 grams of iodine. That's how we got that.
Then after that, we heated it, and the mass of the beaker and the zinc was 30.69 grams. And so with the initial mass of the beaker being 30.13 grams, what we did was we had to take 30.69 subtracted from 30.13, which gave us 0.56 grams, and that's the remaining mass of zinc. And then for part B, we had a crucible mass of 45.12 grams. Then with the sulfate, it was 46.02. So the unknown mass, which our unknown was magnesium sulfate, with the unknown mass being 0.9 grams.
So and after we heated it the first time, we had 45.61 grams total. So then we had to heat it again for the second time, and we got 45.6 grams. So we were 0.1 grams away from the first heat, so we were done with that substance. So then, for all of the calculations to find the moles of the iodine, we had to take the moles, or to find the moles of iodine used, we had to take mass of iodine over, take that over molar mass of atomic iodine, and this will give us how many moles of iodine we get. So then we take the 0.61 grams over 126.9. We get that from the periodic table. And then we end up getting 4.81 times 10 to the negative 3 moles of iodine. So that's how many moles of iodine we had. Then we had to find the moles of zinc. So we do the same thing. I'm just going to erase this right here. We do the same thing for zinc. This is about the zinc reacted. So zinc and zinc. So we had 0.96 2.14 grams, all over 65.38, which again is from the periodic table. And this gave us 2.14 times 10 to the -3 moles of zinc. So then, after we got all the moles of iodine and the moles of zinc, we had to put the moles of iodine over the moles of zinc, and that gave us the numbers of, or the ratio of moles of iodine to moles of zinc. So we did 4.81 times 10 to the -3 all over 2.14 times 10 to the -3. And that's iodine, and this is zinc. So that gave us a number of 2.248 moles. So then this helps us with our empirical formula of this substance, this chemical. So since this is close to 2, it's only 2.2, the empirical formula would end up being Zn, which is zinc, and then iodine, and 2. And that 2 comes straight from right here. So that is the empirical formula of that compound. And that is what we had to do for part A.
For part B, the calculations to find the moles of water was the mass of water over molar mass of water and that would give us the moles of water. Experiment, the mass of water was 0.42 grams and the molar mass of water is 18.02 grams, and that gives us the moles of water being 0.0233. And then for the moles of anhydrous solution or anhydrous salt, you do the mass of salt over the molar mass. And in this experiment, it was 0.48 grams. And then the molar mass of magnesium sulfate is 120.37 grams. And that gives us a number of 0.0039 grams. Or not, yeah, of salt. And then to calculate the molar mass, we did moles of water over the moles of our salt, which was 0.0233 over 0.0039. And that gave us a number of 5.842. this here's the empirical formula for the experiment.
So thank you guys for watching. I hope this helped you out in your lab of determination of chemical formula. Have a good night.